This is Alexi Karve. Today I'll be demonstrating the credit card fraud detection demo using MLFlow and the Red Hat OpenShift data science. So this demo, how to run it, is all documented at this location. The first thing that was involved is to install the Red Hat's OpenShift data foundation and then also install the Red Hat OpenShift Data Science, which of course also means that we have to install the NVIDIA GPU operator. So all of that has been completed. I will quickly show you. Uh, if I go into administrator view and look at the operators that are installed, so you can see that the first thing that was done was install the node feature discovery, which found the GPUs. Then we installed the Red Hat OpenShift Data Science. And if I go to all projects, this is the NVIDIA GPU operator that was installed. And then for the OpenShift Data Foundation, it used the local storage operator to get the persistent volumes, which were on the three nodes itself. And that was used for installing the CIF, uh, which is used by OpenShift Data Foundation. Okay, now let's look at the demo description itself. So what you can see over here is we are going to provide a data set for training. This will be used to train a model in the Red Hat OpenShift data science using a notebook. The notebook code has been modified to use MLflow so that we'll be recording or tracking the experiments with MLflow. And at the end, when the model is produced, we'll push it into the model registry. That model itself is actually stored on the uh, S3 compatible bucket in the OpenShift Data Foundation. And then once the model is available, then what we do is for deploying the model in Red Hat OpenShift Data Science, we use the model mesh serving to pick up the model from this particular bucket and then create an application that will basically call that model and do the inferencing. Okay, so this is basically the steps that we are going to follow. So I have executed all of it. The first thing that was involved was actually installing MLflow. So, okay, MLflow is installed over here. Okay, so this is the MLflow UI. So if you look at OC get pods dash n ML flow, let's look at the route also. So this is the ML flow server that we are going to, and these were the pods that were created for ML's flow. So you can see it uses Postgres. Okay, and this to run this particular Postgres, we had to install the Crunchy Postgres. So once Crunchy Postgres was installed, it is able to install this Postgres, and this Postgres actually uses a persistent volume claim. Let's look at that. So you can see the two persistent volume claims that each of these instances are using. Next thing I want to show you is the OpenShift storage itself. So if you look at the persistent volume claims, these were the local PVs. There are three nodes. So first one, second one, and third one. Okay, so each one has two. So that's why we have total of 6 local blocks. So this is where the OpenShift Data Foundation actually gets installed on the local nodes. And then for Nuba, it creates this additional persistent volume. And if you look at the pods, you'll see all the pods that were required for the CIF, Nuba, and the monitors, the Ceph operator itself, and the OSD that actually the 6 OSDs that are required for one for each per persistent volume that was created on those nodes. And the next thing is I have deployed the MLflow. You saw that. Let's also look at the object bucket claims and persistent volume claims for that. So once we install the MLflow, okay, there is this route that I showed you previously. The place where it stores the models is on this object bucket claim. So this is using this particular storage class, and this is the bucket claim with the name MLflow server. So when we save our models, they're going to be saved over here, and all the experiments which are there, they're going to be stored in the Postgres, crunchy Postgres. And this is where you saw those repos that were created for storing the MLflow data. Now, the next thing that we can look at is we'll go to developer view over here and look at the MLflow. And this is going to show the actual topology, what all has been installed for MLflow. So we see the MLflow server and the other components that are there for it. There is a test that we can run, which they have shown over here. So if we come over here, and now let's keep going ahead. And they say that we need to have the MLflow running. So if you run the MLflow, and then there is a test at the bottom that they tell us to run. Let's see, Helm. So this is what I did to install it. Okay, so I run the Helm upgrade with this one because I have installed the MLflow in the MLflow namespace, but we want it to be visible in the Red Hat ODS applications. So I will show you where we see that. If we come to Red Hat OpenShift Data Science page, so where is the Red Hat OpenShift Data Science? Okay, this is the page. So if you go to applications, you'll see this MLflow over here. Okay, so that appears because we ran this namespace override over here. Okay, and then that appeared. And now to test MLflow, we can run this command, helm test MLflow server. This one needs to run in the MLflow namespace. Let's see. So if we now come over here to the topology, here you can see, that this MLflow test is now running. Okay, so it finished, and you can see the details of what all things it ran. So when it runs, okay, now you can actually go to the MLflow UI. And if I refresh this, this is the Helm test that I had run yesterday. So now that I ran it once more, we can come over here and see, that there are 3 tests that it runs. So those were run, these 3 were run yesterday, and today it ran 3 more over here. Okay, so those tests, basically what they do is run this and check that the output is correct. And since this is the MLflow UI, you can actually see the parameters that were sent, what were the metrics, okay, and you can actually do the comparison of the multiple runs and so on. So all that is allowed. The actual models that you create, they are in this models place. So I have already created a model, and we'll look at how that model was created now. So I will close this window because we ran this test for the MLflow server. So when we actually want to train code using the MLflow, this is the kind of code we need. We need to import MLflow, and we can set the tracking URI to point to this MLflow URL, the route, and then we can do the with MLflow.start run, and that allows us to automatically use the proper libraries that MLflow provides so that we can actually do the logging. Okay, so this is what allows the automatic logging. So we don't have to do it manually for every parameter. It just logs everything. Okay, so we have the Red Hat OpenShift Data Science. We have MLflow. I showed you the visual interface for it. I showed you the test that was executed. Then there are these additional commands that allow us to retrieve the routes for the MLflow server. Then we have to create the Red Hat OpenShift Data Science workbench. So I've already done that. Okay, so if I come to Red Hat OpenShift projects, you can see that I've already created a workbench. I've created a project and a workbench within it, which is this one. And I have the notebook imported into it. I've also created a MLflow connection. So the actual MLflow, okay, so if you look at this OC get OBC -n MLflow. So this is the bucket, where the models are going to be stored. So I have created a connection to that particular bucket. That connection will use, when we actually deploy this model. At that time, we want to run the model that has been saved in this particular bucket. Okay, so first thing we are going to do is now look at how we put the model or generate the model and put it into the bucket. So let's go to the model.ipynb. So this is in the credit fraud detection demo model folder. So this is actually present in this location. Okay, so we have the credit fraud detection demo. There were some changes I had to make to the application. I will talk about them later. But right now we are in this folder, the model folder, and this is what we are currently executing. Okay, so this particular thing shows, that you are going to import the MLflow, and then this is the route for MLflow. And we are going to use that data that we had mentioned previously. We take this data and then we actually train the model. Okay, so this is the basic model that is there. We set the tracking URI to this route that was shown. We gave it an experiment name. And then when we do the autolog on TensorFlow, it's the TensorFlow that is going to be used to train the model for 2 epochs. And then once it is trained, this model will actually be saved into the models folder. So since we have already run this, okay, this was the actual model Python notebook. What we have over here is this particular run. So I had run this, it did the training, it shows the confusion matrix over here. So you see the maximum are over here, 5, 3. There are some problems over here. But this is where the model was saved locally also. Okay, but what we are interested in is this particular part where the model was actually saved into models folder. So if you go back to the MLflow and check this one. So this is the model that was saved. It shows you what kind of inputs it needs. Okay, so these are the inputs it needs, 8 floating point inputs, or 7 floating point inputs it needs. And then the output is going to be 1 floating point. And this is for the batch size. Okay, so right now we can just use 1 as the batch size. And if you want to look at the actual folder, then we can come to this DNS credit card fraud. This is where the model was saved. So you can live. So this is, see, that this is the models folder, and this is where the folder path is for the models. Okay. So since we have already run this notebook, the model has been created, and we can see the metrics that have been produced. Okay. So we can see the metrics over here, accuracy, loss, and everything. Okay. So we can show those details. The parameters for the models we can see over here. So this is the experiment that we had actually executed. And at the end of the experiment, this particular model was saved. So we can see all the details over here. So this is basically the advantage. You can see the multiple experiments and you can see the models in MLflow. And once the model is available, now the next step is basically to run this particular model in production. So to run the model in production, you can run it either in MLflow directly, or we can use the Red Hat OpenShift Data Science Model Mesh. So I'm going to show you how we run it in Model Mesh right now. So you can see over here that I created a model mesh server over here, which is called credit card fraud. And look at this model being served. So I did a deploy model. And if you look at what I deployed, this is the name I gave to the model. Okay, credit card fraud. This is the model name server. The model format was Onyx that you saw. And I'm connecting it to the MLflow connection. Okay, this was the name that we had given for the object bucket claim. And this is the path that you saw for the model. Okay, so this path was basically copied from here. This is the same path. Okay, and then I did deploy. And once deploy was completed, the status became this check mark, so that model got deployed. So if you actually look, to do a get pods in this credit card fraud, so you'll see this is where the model is deployed. Okay, and you can see the actual routes that we are going to use. So the model gets deployed, but we want to test the model. So to test the model, we can either check it from the notebook or we can deploy an application. So in this case, what we did is, in addition to running the model, we have deployed a separate application using the build. So you can see this build that was created. This build was from a particular Docker file. So I will show you that. So this was a Docker file that was used to build this particular application. It's a Gradio application. And this is what this particular application does. So you are going to call the predict, and then the UI actually shows you the predictions. Okay, so that is what it does. So this demo.launch will actually launch the server. And what we have is the requirements over here. So as I mentioned previously, these requirements in the original file, they were a little bit different, causing some kind of errors, but I fixed them over here and this thing works fine. Okay, so now this application was deployed by coming into the topology and changing it to credit card fraud. And this is the application that was deployed. Okay, so to deploy this application, what we do is, in developer mode, we go into add and then import from Git, and you point that Git, that repo that was there, and that allows you to build it. Okay, to if you want to see how to do that, it has been described quite well over here. So let's keep going down. So we deployed the model. This shows all the steps that we just did. Okay, it shows those particular steps over here. We viewed the model in MLflow. Then we served the model. Okay, so you saw that we had a connection. We got these secrets for the bucket, added those, and then configured the server, and then added the model to it. Okay, so all these steps we have already performed. This was the folder path to that particular model. And once we deployed it, the status became green. Okay, we are not doing this optional thing right now, but now what we want to do is deploy the actual application that is going to use this particular model. So this was the model application.py. This is the Gradio application, as I mentioned. What it requires is the inference endpoint. Okay, so that inference endpoint was something that was completed. So after doing the import from Git, it shows what else you need to do. Okay, so you need to set the environment variable inference endpoint to this model mesh serving credit card fraud.svc. Okay, so once you do that, .svc.local, that is going to allow this environment variable to be received, and then it can call it to run the inferencing. So this is the application that you just saw. And now if we run this particular application, you can see over here. Okay, so this is the application that we come to, and there are some samples they've given over here. Okay, I just created my own sample over here. I put those 7 parameters, like distance from home, distance from last transaction, and so on. And if I do a submit, it says not fraud. But if I say distance from home, something like 120 miles, well, it says fraud. Okay, so it basically works. So this completed the demo of installing MLflow, making sure that you have the Red Hat OpenShift Data Science installed, you had the OpenShift Data Foundation installed, and then we actually created a model, saw the model experiments and the actual models in MLflow, and then the model that was present in MLflow, that same bucket, we used it to deploy that particular model in model mesh serving. Okay, so that's it. Thanks for watching.